Hello engineers, this is Dana from Structure Engineering World. Today I will show you how to find critical moment or MCR. We all remember this long equation and today I will show you how can you calculate MCR with one click. Using this software which I made, the name of the software is MCR dozarawa and you can use it to find MCR. I will put the link of the software in the description. You can go and download it. So now let's see how we can use the software. Okay, so as you can see here, this is the interface of the software, and the software is simply using this equation to calculate a critical moment. You have steps in the software, so step 1, step 2, step 3, step 4, step 5. You have 5 steps. Then you click on solve and you will get your result. So let's solve an example here. Previously I was trying to design a girder for a crane, and in one of the steps we need to find critical moment, and as you can see in this step I need to find critical moment MCR. So let's see how we can do it. First of all, step 1, we have a Young modulus of elasticity and shear modulus, and this is the value. It's written by default. If you want, you can change them to any values that you like. So these values are for metal, as you can see, for steel, and in case you want, you can change them to the material or to the value for the material that you are using in your calculation. And as you can see, the unit is Newton per millimeter square. So step 1, in my case, I have steel. I don't need to do anything. Step 2, we have 3 input values. So as we can see, IZ, IT, IW. So what is IZ? IZ is the second moment of area about the weak axis. IT is the torsion constant, and IW is the warping constant. So you need to find those values if you are designing something, or if you are if you are solving a question of the test or something like that. Usually you have these values, they are given. Or you can click here on this button to get some tables that has IZ, IT, IW for the popular or common cross sections that we have for steel. Or you can, as I said before, you can simply calculate them by yourself. The easiest way, if you have a common cross section, is to click here and to find the values. You will get a table and you can find the values that you want. And those tables are from eurocodeapplied.com. This is a website, and the values are from this website. In my case, I have calculated them because I have a complex cross section. So I have calculated the IZ, IT, and IW. So I will just copy the values, or I will write them.
A few moments later.
Remember about the units, we are using millimeter. Then here in the next step, which is step 3, you just enter the length of your element. In my case, I have 12 meter, which means 12,000 millimeter. Then you have K factors and KW. So what are those two values? it's you can find the information here. The factor K refers to end rotation on plan. It's analogous to the ratio of the buckling length to the system length for a compression member. K should be taken as not less than 1, and less than 1 can be justified. The factor Kw refers to end warping unless special provision for warping fixity is made. Kw should be taken as 1. So in case you want to use different values, you should be careful and you should calculate them. Then we have step 4. In step 4, we just need to enter one value, which is Zg, and it's written that Zg is the distance between the point of load application and the shear center. So we have a note here for doubly symmetric sections. The shear center coincides with the centroid. So this is a doubly symmetric section we have here. So in my case, it's different. So Zg, let's use the value. It's written here. 109.42 millimeter. As you can see here, if load is applied exactly in the shear center, Zg is 0. So in point S, if the load is applied here, Zg will be 0. If as you can see it here, if the load applied on the top flange of the section, Zg will be bigger than 0, which means it will be positive. If it's applied on the lower flange of the cross section, Zg will be less than 0, which means negative. Then let's go to the next step, which is the last step, step 5. In step 5, we need to check out this table, and we need to choose those two factors, C1 and C2. Those two coefficients, you can find them here depending on what you have. Depending on the beam element, if it's simply supported or fixed, and depending on the type of the load, if it's distributed load or if it is point load. Usually you will choose these values, and in most of the cases you will choose these values, but in my case I have a special case, so I have different values. You don't need to use them. You will usually choose from here. So if you have a distributed load with a simply supported beam, C1 will be 1.127, C2 will be 0.454. But as I mentioned, in my case it's different, so I will use those values as you can see here, C1 and C2. And then the last thing is to click solve, and as you can see here, you have the result in Newton millimeter and kilonewton centimeter. I hope this software is useful for you, and I hope the video is useful for you. In case it was useful for you, subscribe to the channel and press the like button. And remember that if you want to download the software, the link of the software is in the description. See you in another video.